your badge with you, whether on your phone or print out, you go ahead and come up to the app and scan it. That'd be awesome. Yep, it'll work. The logins on the board. Can you see the tag number in front of your PC down here? What tag number? And then slash student. Yeah, you put a slash in there. Cisco 1 asterisk. Exclamation. Lowercase Cisco, I probably put it like that. I'll rewrite this up here because it definitely looks uppercase. Cisco is all lowercase. Hopefully. Okay. Let's go into your username. You see all the slashes wrong because you have to backslash. Forward slash. Cisco 1 exclamation. There we go. So go log in your PC if you guys aren't already logged in. Did everybody get a handout by chance?
So, he sent us an email last week. Just search for batch in my email.
Yeah, it should be in your RBC email. If you did not get a QR code, let me know. I'll get to it before you leave tonight. Did you not get one?
Let me check here.
Okay. All right, we're going to go and get started while everybody's logging in up here with your QR code and getting logged in your computer. I emailed everybody earlier about this. There's been quite a few jobs posted this week on myrebc.org. In fact, about 6 jobs since Sunday, part-time and full-time, and they all will work around your school schedule. And so if you need a job, we've got one for you. And so everywhere from Ingersoll to, I just met with them yesterday, they need a C++ student. So if you've had C++ and you're interested in manufacturing, it's an awesome place. If you've never been there or heard of it, it's one of the top in the nation for aerospace and automotive manufacturing. They have the largest telescope they're working on right now. It's going to be placed in Maui, one of the big mountains there in Maui. It's the largest in the world, and they're finishing that up. That place is huge, though. I'm working on getting a tour for the students sometime this semester, so you guys will be hearing about that. But if you're interested on that link on myrbc.org, it tells you to email myself if you're interested, so I can get you connected. They probably want to have somebody start like next week, and it will be good pay, and good experience.
What degree of C++?
Just that you have some under your belt. Don't even have to have a whole year under your belt. Just even if you're self-taught, they're willing to work with you, and so it'd be a great opportunity and good for your resume. And they know it's going to be during your time as a student, so and they'll work around your schedule. So the other one is a part-time IT position. This one is at GKN Land Systems here in town, and they're looking for an intern to work in their information services department. It will be a paid internship involving basic IT help desk issues. It says while we would require a fixed schedule, there will be flexibility to accommodate the student's school schedule. There's a direct email in there to email your resume to Mindy Nitz. And so if you're interested in that, that's number 2 opportunity. Number 3, First Rockford Group had one of our students recently leave this last week for a job down south, 20 plus hours per week. Various workstation updates, software support, server environment, flexible work schedule. Ira, who's the student that left there, worked there for 2.5 years. They really loved him, and they want somebody now. So if you're interested, they pay well, $15, $20 an hour, part-time job. Not pretty good for a student. And they're great to work for and work around your school schedule and family and whatever else you got. Trish is the person there that you'd email your resume to, and so that's a good one as well. And then I'll mention one more. Let's go with 2 more. WordPress developers needed. If you have WordPress background experience, they're needing a WordPress person. The email is in that article to email Glenn. And then last, I mentioned a part-time IT position, paid position. This is for an alternative middle school, around 15 hours a week. You would be working around middle school students. And so the email there as well for if you're interested in. So number of jobs available. If you don't need a job, but you know somebody that does, please share that information with them. It's on our Facebook and Twitter as well, and you can share it on your Facebook and Twitter account to kind of spread the word. So I'd like to get these jobs filled for these employers, plus get you guys some employment and students some employment this week. Let's see. Next week, Labor Day doesn't affect us, but if you do have classes here on Monday, don't come to school because nobody will be here. And so just be aware of that. So all offices are shut down, administrative, classes, everything. The next thing I wanted to mention is Cocoa Heads meeting coming up. Let me go ahead and click in here. Let's go to Meetup. Be the best way to go, probably. We've got a meetup.com site for our Cocoa Heads meeting, which is coming up next month, September 10th. The topic says here TBA, but I know it's going to be one of the members is going to be presenting on parse.com, which is a back-end database used a lot in mobile and web apps, and they're going to be presenting how to use parse.com, which is a very popular back-end database for a number of companies. They offer a free account, parse.com, to 1 million iterations a month at no cost, and it's used a lot for mobile app notifications, used a lot for back-end databases for multiple types of web apps. So if you're into web development or you're interested in back-end databases, parse.com is going to be presented next month, September 10th. I know in October it's slated to be, and that meets, by the way, on a Wednesday. It's a Wednesday in 210 for an hour. I provide the pizza, and each month a student presents on a different topic. I know in September or October, the student's going to present on an app idea that he would like some help with. And so, yeah, every month's a little different on whatever it is the students want to present on. Last month it was on, I presented in the summer on how to set up a Raspberry Pi and set up a web server, basically a virtual Dropbox using the iPhone as internet connection, and basically like a mobile Dropbox for meetings where you could share files. And so anyway, avail yourself to that. It's you can just type in meetup.com and search for local meetings and technology, and Rockford Cocoa Heads will come up, and definitely avail yourself to that. Okay, tonight we're going to go over chapter 1, but before we do, I want to get into week 2 assignments first. You've got this week chapter 1. We'll do the lab in just a second, which is part of the handout that you've gotten. We're going to go over some content on the board, and then do the lab, and then we'll be done. Review questions for chapter 1 and quiz for chapter 1 as well is due. And so any questions on what's due coming up? Okay, cool. Also wanted to make mention, let me go back here and make it sure it's in here. In the modules, let's see. Yeah, I think I mentioned it last week. I want to mention it again. Research paper topic. It's in the modules. If you go into our course and click on modules on the left side, at the very top where it says 0 research paper topic, I don't have a due date on this one. I'm not going to grade it this semester for the topic submission, but I'd like you, if you could make note to yourself, to send me your research paper topic a week from this Sunday. A week from this coming Sunday, you have to decide on a research paper topic. And I'll go to the bottom of that document in the top of the modules and give you some of the topics to choose from. Apple Talk and Macintosh networking, copper cabling, email protocols, fiber optic data cabling, IBM SNA, ISDN DSL cable modem, malicious code, multicasting, NetBayou, network management, networking hardware, networking with Windows, Novell NetWare, OS2, point-to-point protocol, remote access, server hardware, TCP/IP, the internet, token ring, Usenet, VPNs, wireless networking, and then an elective topic that has anything to do with networking you can choose. And so just email me your choice of topic a week from this Sunday, because you'll be presenting a 10 to 15 minute presentation along with a 5 to 7 page research paper, which it explains it in this 0 research paper presentation document at the top of our modules. Questions on that? So note on that, I'm not going to remind you via email or anything, so just make note to yourself to send me your research paper topic a week from this Sunday. All right, so let me go ahead and switch over to Keynote here. So we're going to go into chapter 1 and specifically talk about basic terminologies and makeup of a network, and some terms that we'll go over on the board as well, and drawings. And then at the end, when you guys do the lab, you're going to work together on, as a team, to create a brainstorm together to create a network layout for a number of computers, servers, switches, printers, and put it on the board. I'll split the board up into 3 areas for you guys to play with. So we're going to look at some advantages of networking computer over standard standalone computing. We'll look at distinguishing the difference between client servers, we talked a little bit about last week, and then elements to all client server architecture. We'll look at specific uses of networks, certifications we'll end on. So let's first start out with why use networks. Well, I'm glad you asked. Network is a group of computers and devices that's connected to some transmission medium. In here, The back of your computers are connected to a Cat5 cable, which goes to this box in the corner of the room. From the box is a number of switches in that box that you guys can definitely look at before you leave. I haven't heard anything that should be open. In here is a couple of one switch, a PIX router, and a patch panel. The patch panel at the very top has cabling in it. In fact, let's do this real quick. Just go stand on up, stretch your legs a little bit. We'll just look at it instead of trying to have you visualize what I'm saying without looking at it. So let's look at it real quick. Okay, so here's a patch panel. Patch panel has all the Cat5 cables. They're actually numbered, and your guys' ports have numbers on them as well. So if we were to trace each one of these, we could trace them back to all the computers here. This is a patch panel, which you can learn how to do and do this for a living, just patch panel only. Below that's a PIX router right here. The PIX router actually gives us internet here. Mainly, we have some rules set up in there for like FTP, rules set up for pinging. I'm not allowed to do that outside of the building. Beyond that, it's fairly open. We're open in here to everything. We're not behind the RDC firewall. That's it, and system labs. Then this here is our switch. Switch is also, these wires here will come to the back of the from the patch panel into the switch. Behind the switch is going to be fiber cord. The fiber cord actually is right here, orange cord, goes into the floor, and from the floor goes over to the IT area. From the IT area goes into the Cisco lab, the other Cisco lab down the way. And that's where our server's located for us to have network capabilities in here and internet capabilities. So again, patch panel, PIX router, which is really small. These have rules and files set into it. Same with the switch, has rules set in as well. And that's the black box. We're going to be moving this, by the way, to the back of the room eventually. But you might have noticed these around campus in different rooms, and that's what they look like inside of it. So you'll learn a little bit about all these devices this semester. So I thought I'd show it to you. I thought it'd be kind of cool for you to see it versus me trying to explain it to you with the door open. Nobody looking at it. So you're sitting down in front of a computer. That computer, again, is connected to a medium. Other mediums that could have, or media that could be connected, could be fiber, which is in the patch panel there. Also wireless, which we all use. Cellular also is a media type as well that we all use. And there's other ones that we'll talk about this semester, like point-to-point technology. We have outside of the building, when you walk out tonight, to the right, it's kind of dark when you leave, but in the corner of the campus over here, we have our farm of point-to-point dishes over here that are painted black and green and different colors. And they actually literally point to different locations here around Rockford. In fact, you guys know where the quarry is going down Mulford. Keep driving, keep driving, keep driving until you get to Perryville on our left, around the corner. If you look up, there's a tower. We have a number of dishes on that tower to point to different locations, but it originates here on campus right here. Those actually all point to that direction there. To where we can do like simulcast and things like that to local businesses and other colleges. So a standalone computer, not connected to any network, and really there's not a good example of that anymore today. I guess the best example might be if you work in a workplace that has an old computer that's connected to, that does some processing or whatever, that is not connected to the internet, not connected to the network, they don't want it to be connected to the network for whatever reason, might be security reasons. But you know, your home computers today, your laptops, your phones are all connected to a network for the most part. But before the networks existed, there was just standalone PCs, and there still is need for that. But for the most part, you guys are always connected, whether it be wireless or wired, anywhere you go. Standalone computer uses local software and data. Advantages of networks is that you can share, devices can share multiple users. And so your desktop that you're sitting at can be set up for everybody to log in with an individual login, even though we all log in with one login. Normally in a workplace, you log in with a unique login, or downstairs you log in with a unique login, right? Anywhere on campus besides in Cisco labs, you have your unique login. And the advantage of a unique login is security. One of the big advantages, not just that your stuff is your stuff, but nobody's going to get into your stuff. And you're going to be able to work on your stuff without anybody tampering with it, which is pretty important when it comes to your work environment. Not that you don't trust your coworkers, but people can make mistakes and people can delete stuff, and you might work with people that like to delete stuff. Well, it's nice that they can't get into your stuff to delete your stuff. It's okay if they delete their stuff all day, but if you ever had anybody delete your stuff or you've inadvertently deleted your own stuff, it's kind of crazy. And so by having the authentication to log in, it helps us to have that security. It also saves time and money to be connected to a network, because before networks, for us to talk to one another, or for me to send you a file, I had to mail you that file, right? Email didn't exist. Have to maybe fax you that file for you to get. And so a lot of cumbersome things, or maybe meet face-to-face to literally hand you the file. And the other advantage is central network management, meaning all of our important data should be backed up on the file server, and we'll talk about what that is tonight. Some of those backups are done daily, every 30 seconds, once a week, once a month, and those backups, for the most part, most organizations are stored off-site on a nightly basis, just in case something were to happen to that organization, that building. They could be up and running within X amount of time and back in business. So a lot of advantages of networks. There's different types of networks, like where you position your computers, control levels over shared resources, communication and resource sharing schemes. So different ways to, like, say, segment a network to where this half of the room can talk to each other and this half of the room can talk to each other, but you can't talk to, each segment cannot talk to each other for security purposes. Military does that. If you're whatever level of military you are, that's also the level they've set up the networks to be. Each level cannot talk to one another in some areas because of security. Need to know, things of that nature. But also banking does this. Education does this for sure. You're not going to have access to everybody's account information. You're going to have access to your own, but not to everybody's. And so there's some segmenting, security goes on there as well, and control. There's network models. We talked about these last week. We did the little poll asking you some questions about. One of them was peer-to-peer, which most of you got right, which is basically just two computers connected to the other to talk to each other via whatever medium that might be. It might be a Cat5 cable, might be a USB, might be wireless. And then client-server. Client-server is where you are connected to a server, and then everybody in here also is connected to that server, to where you can share resources, share database, share files, things of that nature. And all critical data should be stored and worked from off of that server. And why is that important? We talked a little about that last week. Why is it important to work off of critical data off a server versus a local PC? What's some logical reasons for that? Yeah, which happens, right? PCs break down, they crash, blue screen. If you've not had that happen, you will. It'll happen. Just the nature of the beast of working with computers. And so, but if you have all your critical data on a server, it's just a matter of replacing your client computer, reinstalling operating system and software, and you're up and going. You're back to work. And so that's how IT departments function. Clients are generally dummy terminals, you could say. They have OSs on it, they have programs, but they should never have critical data. And if folks are storing critical data on there, they probably need to be trained not to. And there's companies that do it. Maybe you're one of those companies that you work at that they don't really care where you store your data. And maybe it's not educated to that level. But all it takes is a project you've been working on for months and months and months on a PC, and that thing crash, or the hard drive crash, or whatever, and you lose it. Oh man, I should have saved it to my personal drive. I should have saved it to a network drive. And so that's a benefit of client server for sure. So direct communication on a peer-to-peer is Meaning, what that means is, if I'm connected to you on a peer-to-peer network and we're sharing files and we're working every day, where some small offices do that because they can't afford a file server and a network operating system and a fancy network. And it does work, and I've worked in offices that function like that. If we have that type of setup, we have equal authority. What that means is, I don't control your computer, you don't control my computer. We're both on equal footing when it comes to authority of sharing files. Now, on a peer-to-peer scenario, you can block people out from getting to files on your own computer, but I can't control what you do on your computer. But in a file server scenario, client server scenario, you can definitely do that. You can, as a server, control what people do and don't do by rules you set up on their login. And we'll talk about that this semester. Individual resource sharing is also available on peer-to-peer. You can share resources, like we can share files, we can share documents with one another. It may prevent access to resources, meaning if I don't show up that day or my computer's shut down and you can't get in, you can't get to the files we're sharing, that I'm sharing with you. If my hard drive crashes or my computer locks up, you're not going to be able to get to that file. Even though it's there and you know it's there, you can't get to it because my computer is disabled. Traditional model of peer-to-peer is 2 or more general-purpose computers connected together just for the fact of sending and receiving data back and forth to each other. And an ad hoc type of scenario sometimes. But in some offices, they do function fine in a peer-to-peer scenario. There just are dangers to it. So here's a screenshot of a peer-to-peer type of scenario. Everything from a desktop, laptop, mobile device, all sharing data on a simple peer-to-peer network. You know, you can share data today via Bluetooth. You can share it via USB, Wi-Fi. You can set up ad hoc Wi-Fi to each other and connect easily with all devices, regardless of the OS. Anybody with a phone or a laptop can set up an ad hoc Wi-Fi for other folks to share and to connect to that network. Advantages of a peer-to-peer: it's very simple to configure on all OSs today, regardless if it's Linux, Droid, iOS, Windows. They're all fairly the same as far as configuration of networking peer-to-peer. It is less expensive because all you're dealing with is either a cord, or if you have Wi-Fi, if you're using Wi-Fi, there's really no expense because you're just turning on ad hoc Wi-Fi on your laptop for another person to connect to and share files. Done. And you might have done that. If you've not done that, it's fairly easy to do on all platforms. Disadvantage is not flexible. No growth really here. It doesn't necessarily have security wrapped around it, because the peer-to-peer networks that you do have out there that tell you they're secure are cumbersome and really clunky to connect to and not practical at all. So it's really meant to be in a non-secure environment, just share files quickly and then shut it down. It's not practical for large organizations, say like, you know, Rock Valley College, or your business if it's over 5 people in it. Not real practical to do because it can be very cumbersome and things can happen, just like we talked about tonight. Clients can die, PCs can crash, and if they do, and critical data is on those PCs, then you're shot in the foot. Okay, but it still happens. People still use it. I still use it. You know, ad hoc type things to share files with folks and with students and coworkers. So on a client-server network, you've got the server, and the server is that central computer within the network. And here in this room are servers in the Cisco lab down the hall, and it's basically what gives us your IP address when you log in, which you'll find out what that is this semester. It casts out what's called a DHCP server on that server to give us an IP address. It facilitates communication and shared resources from that server. And then clients, the one you're sitting in front of, is workstations, to where you can fire up the OS, fire up a program, but then grab all your important data from the server. It's a central resource controlled sharing by the server, and that server can share data, it can share space. Like an example would be most networks give you so much space per person, right, logs in. It can be 5 megs of space to unlimited, depending on your organizational needs. It also can share devices on a network, and no direct sharing of client resources is needed because you're sharing everything from a file server only, from a centralized area. The computer roles on a client-server network is you've got your server, you've got your clients. The clients run local apps like Microsoft Office, like Internet Explorer, Chrome, IE. List goes on and on of apps where you run Photoshop, whatever, Dreamweaver, Visual Studio. And then data is stored locally on a client. You can store data locally. I don't recommend storing critical data, but you can store other data locally. And then using server shared applications like Microsoft, you can push Microsoft apps from a server to clients. You can push Adobe to clients. You can push Quark to clients, Quark Express, which is a popular graphic design software. InDesign, another one. These are apps that run from a server, and it'll actually keep track of the licensing for you as well. You can use a server as an intermediary device, or the client as an intermediary device for transfer of data, transfer of application data, and then communication, switches and routers, which we'll talk about. You saw some tonight in the box there. We showed you a PIX router and a switch. And basically the routers are the smart device on a network that has rules set into it, like what comes in, what goes out, what can go in, what can go out, to be really easy to explain, try to be easy to explain here. Routers also can block communication. Like say I'm going to block FTP in my router. I don't want anybody to upload anything from our network. I don't want our networks to be pinged. When a client comes into our network with our IP address, it's going to go to this computer that has my website on it. So all those rules can be set in a router. And you can take classes here on campus to show you in Cisco how to configure routers and also switches. Switches configuration is specifically on the IP ranges of a network. Every switch is going to have a certain IP range it falls upon and works in, and the switch knows that because it's programmed in what it's going to be. And so there's no surprise to the switches on what's going on. And this semester we will play definitely with old school hubs that you can't even buy anymore, and then also look at some newer equipment in here as well, right off the shelf. So here in the client server architecture, you've got on the upper left a workstation, then you've got on the upper right a server. In the middle is a connectivity device that connects everything together. Connects the client to the printer, the client to the client to the server. That intermediary device, that connectivity device in the middle, has all of the, we'll say, Cat5 cables coming from these devices into the switch, and notice from the switch there's a wire running to the server. And that's how the network works. And one of these weeks coming up here, you'll learn how to create the Cat5 cables. And these cables here are called straight cables. And what that means is on both sides of the wire, it's the same wire schism. It's the same wire mechanism end to end. On a crossover cable, there's 2 wires that are switched on both ends. And the reason for that is, the reason straights work here is because that connectivity device serves as a switch. It serves as the switching mechanism to cross over to talk to the other devices on the network. A crossover cable, you can literally connect 2 computers together and it talks just fine. It doesn't need a switch in between. and you'll learn how to make both this semester, a straight cable and a crossover cable. For the most part, most of you probably won't be doing cabling for a living, but it's nice to know how to do it if you need to do it. It is much more cost effective to do it yourself if you're having to run a whole bunch of cable in a business. And it's not real hard to learn. It's time consuming, but just like anything, it's worth learning for sure. And it's not real hard to learn and fairly easy to learn. You know, I've had to run over the years in some buildings like 1,000 Cat5 cables over a summer or something, and have 30 days, 60 days to do it. And so it's a lot of fun. You get people to work with that can have fun, and it doesn't always work. You mess up on them. You start over again. But it's much cheaper to do it yourself than it is to go buy them completed for you. And so you'll learn how to do that. Server requirements are different than operating system requirements for clients. You do have your own network operating system. Windows has it, Linux, Mac even has their own OS server. They got rid of the hardware part, but they still have an OS X server that you can still purchase that some of you might have worked with in the past, possibly. But the network operating system is uniquely different than a client operating system like Windows 7, Windows 8, Windows XP, Windows Vista. What it does, and is specifically designed to do, is these bullet points here. It's designed to manage client data and resources. It's designed to ensure that authorized users can access the network. Clients can't do that. Client OSs can't do that. It controls how users access files. It controls and restricts network access. On a network operating system, I could set it up to where my workers can only log in from 9 to 5. If they try to come in before 9 a.m., they're not going to be able to log in. If they try to log in at 5:01, they're not going to be able to log in. And so you can lock folks down with that, with a network operating system. You can also dictate computer communication rules. Okay. You can also say you're only going to this list of websites, and that's it. You're only opening these programs on your computer, and that's it. Okay. And one of the ways you can do that in network servers is with Active Directory. Active Directory allows you to set up rules for users. And these rules are dragged down to the local client, and these rules say you can only access Microsoft Excel, go to these 3 web pages, and that's it. You can't install programs, you can't use a USB disk drive, you can't use a CD-ROM drive, you can only do these 5 things, and that's it. You can literally lock your computer down to do that with Active Directory on a network operating system. Can't do that on a client only, client OS only. It also supplies applications to clients, which I've mentioned. There's some applications designed specifically to be deployed and can be deployed upon a network, and keep track of the licensing. And there's two types of licensing on apps. There's the concurrent licensing, meaning if I have 50 people in my place of business, but I know only 25 of those are going to be connected at one time, so I'm going to buy a concurrent license of 25, meaning 25 of my people out of the 50 can be connected at one time. If 26 connects, it won't let them in. And you can do that with some applications on a server side. So that's concurrent licensing. Then they have site licensing, meaning you can buy a license for the entire site, however large it is. Now, granted, it's going to be much more expensive for a site license, and probably more feasible for most companies to just do concurrent licenses. So server examples: Unix, Linux, Microsoft, Mac are the most popular. Out of these lists on the text here, Linux, Microsoft, and Mac, I would say the top 2 would be Microsoft and Linux. Okay, those are the top 2 servers. In the business world, you got Microsoft. In the web world, for web pages, you got Linux. There's a few Mac OS servers around, like, say, for multimedia businesses, radio stations, radio, TV, magazine, newspaper. They all have Mac servers because Macs are more designed to run multimedia, like QuickTime video, rendering, Pixar animation, has tons of Mac servers. Steve Jobs, who bought and created, and one of the creators of Pixar, brought his genius into part of the rendering we see today is because of the Mac OS. And the Mac OS that we're on now currently actually is a rendition of the original Pixar animation machine that was involved with Steve Jobs in between the time he quit Apple or got fired from Apple and came back. And so, so the Mac OS is still used a lot if you're a graphic designer. Probably more likely you're going to work in the Mac OS, Mac environment. In media, same deal. Just the nature of the beast. Macs are more designed, you probably already know this, to the multimedia side. Windows are more designed to the business end. Email, Exchange server, Office. So you got two worlds. So on the Linux side, most web servers, and I think I mentioned this last week, are ran off of Linux servers. Red Hat's a popular Linux OS. You've probably heard of like Ubuntu, I'm guessing, Kubuntu, and those are good client OSs for Linux. But Red Hat and SUSE Linux are probably the top two Linux servers that run web servers and that do run business level authentication like a Microsoft server does. Because you can authenticate and do everything just like you can in the Microsoft world and the Linux world and also in the Mac world. You can do it on all three platforms. So server features relative to clients. Well, it makes sense that servers are going to have more memory. Example here in this building, we have servers that have, one server I'm thinking of has something like, what is it? Each processor can have 12 gigs of memory. Each processor can have 12 gigs of memory, and it's 10 processors, so whatever the math is on that, for one server. And so 128 gigs of memory. So they can have a lot of memory, processing power much more, storage capacity much higher. They're equipped with special hardware. An example would be servers have backup connections to it, backup mechanisms to it, like Seagate is a popular one, HP is a popular one. What I mean by that is these devices I just mentioned, these hardware devices, literally back up terabytes of data on a daily basis in some locations, and that's all they do. Exchange server might have connected to it a Barracuda firewall, possibly. Barracuda firewall is an appliance. It's a hardware appliance that connects to specifically Microsoft operating system, network operating system. And so there are some special equipment that can also connect for network management, and Barracuda would be a really popular one. Disadvantage relative to peer-to-peer. As you can imagine, they can be quite complex, and maintenance can be really expensive. But most businesses cannot survive without some type of small area network, small LAN, and it's really not that expensive to get up and running. You can definitely get expensive, but you can also design a network to be fairly cost-effective. I mean, if you want to be totally almost free, you could set up a Linux server, which doesn't cost anything to download and install. You'd have to deal with the hardware to install it. You have to run the wiring. You have to get some type of switches, maybe some Cisco switches, and maybe a router, PIX router. So you're talking everything I just mentioned with a free Linux operating system for a small business of, say, 25 users, probably about $5 grand. Probably about $5 grand for that whole bit right there. But you have file server, you got authentication, you got file storage, everything. And so if you do low end for Windows network operating system in the same scenario, everything I just mentioned, but add Windows operating system, network operating system versus Linux, you're probably talking at least 12 grand, 10 to 12 grand to start out, just for licensing for Windows for a year for that many people. And so a little bit more expensive for Windows, but you might need it because you might want to use all the stuff Windows has to offer and everybody's used to using, right? Microsoft Exchange, Microsoft Office. So advantages also relative to peer-to-peer. user credential is assigned from one place, meaning not from your computer, but from the server. It's assigned from one place. Like my son lives in Springfield, Missouri, but he logs in every day to a server in Georgia. And the people who work in Rockford for that same company log into Georgia as well. So it's all a centralized area. Multiple shared resources can be accessed centrally. Central problem monitoring, diagnostics, and correction can take place as well. Optimized to handle very heavy traffic, very larger loads, and then can connect many computers on the network and are more scalable. You can add more computers, just as simple as adding another switch maybe, and then 20 more computers. So it's a lot more scalable than a peer-to-peer. So the evolution of LAN, the local area network that you're learning about this semester, is confined to a relatively small space. LAN is. An example would be this room, this floor, this building would be max amount definition for a local area network. Started in the 80s, and it became popular as peer-to-peer based was. Peer-to-peer based used to be called sneakernet, basically. It's kind of like, because you had to get up and move around to connect to one another, wearing your sneakers, so they call it sneakernet. Today, much larger and complex than back in the 80s when it started. So you have LAN, which would be this building, we could say. And then MAN would be, it's called metropolitan area. It's connecting servers from multiple buildings, like here on campus. We have this building, the PEC, CL1, CL2, New Jacobson Center. Those would be considered a metropolitan area network. And the way they're connected on campus here anyway is we have multiple tunnels underground that are large enough for a golf cart to go through, that have fiber running in those tunnels that connect it to fiber on each building. They have a fiber drop in each building in the basement, that from that fiber drop, it goes throughout the building into boxes like this in every classroom. But it's fiber from building to building, and then from the fiber drop, box to box is fiber, but then box to computer is Cat5 cable. Because fiber is much more expensive, but fiber can run a longer distance without data degradation. Cat5s can roughly run anywhere from, they like to say, like 150 feet, but I've run it as far as 250 feet, 300 feet, and that's probably max. Let's say to keep it with like 150-foot range. If you have more than that, get another switch and add some more lengths of cable in between. So you got LAN, you got MAN, and so here's what it looks like. A MAN and a WAN, or MAN and a LAN here on campus. But then let's say we've got Stenstrom Center, right? How do we connect that? Well, we have what's called a WAN, a wide area network. A wide area network connects generally via the cloud, via internet connection, whether it be T1, T2, T3, ISDN, a direct link, whatever. But anytime you hear of WAN, it's always generally via the internet. You're connecting to another network on the backbone of your internet provider, whether it be AT&T, whether it be Comcast, Verizon, whatever it might be, as a backbone. Anything that travels across that backbone would be considered a WAN connection, a wide area network. So campus to campus would be WAN. Here in this building, LAN. Building to building, MAN. Make sense? And so you got LAN, MAN, WAN. And the only way to figure it out and to keep it straight is LANs are generally combined to a building, MANs have multiple buildings, and then WANs can be geographical spans of locations connected by the internet backbone. Make sense? Pretty basic. And that's why I just explained the WAN. It could be different, like Microsoft, you know, is an example. They have offices all over the world. Apple, same. And they definitely are connected by a WAN And so if you log in anywhere in Microsoft, for the most part, you're going to log somewhere in that process in Seattle, Washington, during that connection. Apple, regardless if you work at any Apple store, when you authenticate on an Apple computer and you're on their network, you're going to be hitting Cupertino, California, somewhere in that location of network, because that's where all the main servers are for both businesses. So Seattle for Microsoft, Cupertino, California for Apple. And so, and the list goes on and on. Sears, JCPenney, all these large stores and chains of stores have central offices where folks generally log in via a WAN connection somewhere. So you also have a simple WAN, which is basically multiple locations. And notice on each location, they have a router on both ends, and that router has a WAN connection via the backbone of the internet provider you have, and it has rules set up on the router to determine where things go when they come in and go out. An example would be logging in. Let's talk about that. The people on the left are logging in. We'll say the people on the left, right is the authentication part of the business on one of those servers. And so anytime a user logs in, it's literally mapped on the network routers when a person logs in on the left network or even on the right network, and the router is determined specifically on the left where that IP is going to be going for that authentication. It's not going to be an internal IP address, it's going to be an external IP address, so we can get outside of the router to connect. So elements common for client server. On a client, a network computer requests resources from another network computer. The client workstation human user. Client software is installed on the workstation. Server has network computer management shared resources. It runs network operating system, as we mentioned already. And a workstation is a personal computer that may or may not be connected to the network. A lot of times these are like BYOD, bring your own device type things that are real popular today that people bring to work, and so they may or may not connect those to a network. We'll be doing this semester, a NIC card. You'll learn what that's about, and it's basically what connects your Cat5 cable to the network, and it's a network interface card. It's a device inside your computer that connects you to the medium, whatever it might be, and here it's a Cat5 cable. Most network interface cards today are soldered onto the motherboard. The ones we play with in here, you can actually take the card out and reinstall it. And the reason they're soldered today is for cost effectiveness. And it's not just on laptops, even on desktops, a lot of times on the motherboard they're actually soldered in. It's just a little black, like here's the motherboard, will be soldered in on the end, and that's it. We'll be actually dealing with a card, a NIC card that actually is embedded onto or popped into a slot on the motherboard, and then the Cat5 cable has a slot here to come out, and so it's an actual card interface. You can still buy them for your desktops. Laptops generally, if a NIC card fails, if you don't have warranty on it any longer, you generally have to buy a USB to NIC, which you can buy, which work. Macs have Lightning to Ethernet, and so it's not just a NIC port or a NIC card anymore to connect to Ethernet. You get multiple different types of devices to connect to an Ethernet port. But they all serve the same function of a network interface card, connecting your computer to the network. And then network operating system, the NOS, is a server software enabling the server to connect and manage users and groups. And I want to talk about this up here on the board, this beautiful drawing, which no, it's not, but it's good enough to get us going here anyway. Basically, anybody familiar with a tree? Okay, you're good then. You're really good. Okay, at the bottom of a tree is what? So flip it upside down for networks. Instead of the bottom being a root in a network, it's the top. Anytime you see diagrams or drawings of a network diagram, it's always flipped upside down from a tree that we normally think is, roots down here. So the root is the top of a network. We'll say the root in this case, to pick on Microsoft, is Microsoft. This is the root name of the network, Microsoft. And then after the root, you have what in a tree? What's right after the roots? What comes up from it? The trunk, right? So you've got the trunk, and the trunk is basically then connected to what? Branches. This is the trunk here. So the trunk of a network would be this right here, basically. And what it is basically a foundation for all the branches. And the branches in a network are, to be easy here tonight, departments. Departments. And I'll just focus on this side over here. So you got some branches in a network, and a branch could be considered groups of users, like Department 1, Department 2, Department 3, apps, with, say, multiple apps in there. But notice here, you got some leaves. So you have root, you've got your trunk, you got your branches, and then finally you got your leaf. So can you add a branch to a branch? Can you add a branch, a sub-branch type of thing? You can have multiple branches to the trunk of a tree, right? And even a branch itself can branch out other branches. Same thing on the network. I can add from a group, which is a branch, multiple other groups, which I've done here. But then there comes a point, like in user groups, which this is, once I set up my user groups, I can right-click and add multiple other entities. So this is just called groups, and I have group 1, or Department 1, Department 2, Department 3. These are groups as well. But within each department, I'm going to have multiple leaves, which are users. These are users, and I can't add to a leaf. A leaf is the very end of a tree, right? It's the very end of a tree. You can't add to a leaf. Same on a network. And the networks in diagrams you'll read, and as the semester goes on and you look at diagrams, there's a lot of network operating systems that diagram networks as a tree of some type, whether it be Microsoft, Novell, Linux, Mac. And the basic concept is pretty easy, except it's reverse logic from a tree. You got the top as a root, your branch, your trunk, branches. You can add to branches, but you can't add to a leaf. So leaves would be users. Leaf would also be a printer. Leaf would also be a file server. Okay? Can't add to a file server. Can't add to a printer. Can't add to a user. But I can add to a group of users called Department 1, Department 2, Department 3. I can add to a group called apps that has 10 apps in it. And so each network operating system will allow you to do what I'm just mentioning. I can add to, say, if I go back a little further here, let's go to, even though file server is technically a leaf, I can, though, have within the file server a group on the operating system called, just for diagramming purposes, called printers. And within printers, I can have a whole bunch of printers out here. This will be my group of printers. And then these will be the printers themselves will be the leaves of that group of printers. So diagramming-wise, that's just it. It's a diagram. It's a way for networking folks to logically lay out their network before doing anything, before buying any hardware, buying any software. And why do you think it's important to diagram, however you diagram, before you buy anything? Why do you think that's important?
So you know what you need to buy.
Yeah, so you know what you need to buy. Are you always going to be 100% right when you diagram something? No. If you've ever been in construction, maybe, or bidding on something, maybe, you always forget something, right? And that's going to happen as well in networking when you're diagramming a network, which we'll do here in a second, and laying it out. But it's good to start out with the branch scenario, the tree scenario of what kind of is going on with my network here. And the great thing about it too is in a scenario like this, you can also branch out future stuff. This is my future branch of, say, my business is branching into China, and we're going to go over there. I don't know yet what that's going to be, but we're going to go ahead and put a branch out there for China just because we know what's going to happen in the next 5 years, and we can look forward budget-wise on what it might cost. The bottom area we'll get to in just a second, but I wanted to focus because we're talking about on the slide there, managing groups and users. That's visually basically how it's done on the top part. You're definitely going to spend days and days on end, sometimes brainstorming these things, but that's kind of to get you started anyway to understand. Yes?
In programming, like when you're doing the flow charting, there's the universal, I guess, shapes.
Right.
Is that applied for networking as well?
Yeah. No, not really. Every network operating system will diagram a little different. The logic's the same, though. The logic's the same. You're right in that the logic's the same. The shapes and things might be a little different of, like, say, what a root looks like, or a branch looks like, or a leaf looks like, but the logic's all the same. Yeah, definitely. And there's actually software you could buy, free software, commercial software that'll let you kind of do this graphic, kind of like Visio or something like that. That'll let you do that. The next one I want to talk about here is an actual screenshot here of a NIC interface card. Here's the soldered ones I talked about right here on the board. But then also you've got slots here on the motherboard available for expansion. So these die, which they do sometimes, you can buy a NIC card from the store for like 30 bucks and install it, and you'll be good to go. And we'll do that in here. Client-server network architecture, some common elements. You've got the host, which is a computer, enables network resources. You've got the node. And I always tell students in this class, the first node of every network is not a machine or a file server or a switch or a router. It's a person in networking. It always is. And we'll actually have one of the labs we do this semester where you do a troubleshooting lab, and I'll give you a whole bunch of user problems, and you get the opportunity to take those user problems and be a user with that problem with some emotions in there, some don't follow directions, you get to be that person, plus you also get to be the troubleshooter to try to figure out what the problem is and then reverse it. So you get to kind of do both and kind of get to a real life scenario of how that node scenario is a person, that first person on the network. Then you've got client server and other devices of the node, communications as a node. Each node is generally identified by some unique address, whether it be IP address, a network address, which you'll learn about that this semester. And then also connectivity device, allowing multiple networks to be a part of one network to exchange data. And connectivity devices you saw at the first of class in that little black box, which is a switch that's in there, and the PIX router. Segments is basically a group of nodes connected together, so we have multiple boxes on campus on this floor that all connect together into the IT room. They use the same communication channel for traffic. Then we have backbone. A backbone technically is what your network works on, what it flows on. Like in here, we have a backbone of Cat5 and fiber in this building. In this LAN, in this MAN, same deal. Cat5, fiber to Cat5. But we also have a WAN as a backbone, which would also be your terminology like T1, T2, T3 connection. It's basically called the network of networks, a backbone is. And then topology, there's different topologies we'll look at in a second. How computers are laid out, there's a ring topology, a bus topology, a star topology, and a hybrid topology. And we're going to end on these last few slides on topology, and then we'll do our little lab. So here we have LAN backbone. We see here, we can pretend this is we'll pretend this is a fiber, and then these are Cat5s. And that's the actual backbone. And so if somebody would say, what's the backbone of your network? You would say Cat5 fiber in this scenario. Here is an example of different types of network, and that has to do with the handout I gave you, which we can look at. It's a little different than that one, but same terminology. Let's start with old school. Old school bus. Anybody have cable network at home or cable TV at home with Comcast or something?
Yeah.
You know, the coaxial that runs to your TV. That was the original medium for networks, is your coax. And it ran upon coaxial, just like at the top left, and it had the NIC card had a coaxial input like the back of your TV, and that was called a bus network. Very fast, just as fast as Ethernet today, but also very expensive because it's much more expensive to create those coaxial cables than it is to create a Cat5 cable, just material-wise. Then you've got the next in the evolution of networks goes from bus to the ring topology. The ring topology a lot of times still was back in the day where you had the coaxial, your cable that you're used to at home on TV, but it would have the way ring works is this. Every time, if I'm at this computer, want to send data to this computer, I duplicate data on the left and right node of my network, and it travels along the network until it reaches a destination. So if it's going this way, it's going to duplicate, and say I want to get it to this computer here. Duplicate, then duplicate. Then when this computer finally gets 100% of the data, then all the data is then dropped from the nodes it's connected to. So a lot of redundancy in a ring network, but the data is more sure to get there. Ring topologies still exist in military and in banking because New York Stock Exchange, heavily ring, military, heavily ring topology. Still using Cat5, but a lot of times in ring topology you have two NIC cards in each device, an input and an output of that network. A lot of redundancy, but data gets there much more, not that it doesn't get there on other networks we'll talk about, but it gets there more assuredly than, more guaranteed than, and faster sometimes than other topologies. Top right, star, that's the newest topology, started in the late 80s, early 90s actually, early 90s on star. And that's basically where you now have a switch in the middle, or back then it was a hub, a dummy hub, that connected all these computers together to share resources with a server, a file server of some type. And that's basically what we have today. If you build a new network today, it's going to be a star topology. It's going to have your switch is going to be connected to your file server, to computers, to printers, PIX router. But then the bottom right is generational, as you can imagine. We'll say Ingersoll, which is one of the jobs I mentioned earlier. They've got all four of these in their networks because they're so old. Iterations of generation, decades of networks. So it doesn't make sense. Even say they have an old bus topology in some parts of the building and it works, why tear it out and replace it if it works? So a lot of times you will walk into older buildings that will have the hybrid type of scenario that you'll have to deal with. But for the most part, if it's a newer business, you're going to be dealing specifically with star only. So let's do this. You guys want to take a break or go right into the lab? It's up to you. We'll take 5 or you're good?
Take 5, 2.
Let's do it. Let's take 5, we'll come back and we'll hit it. And we'll get in groups and we will do the lab. And for those of you who don't know the building, restrooms that way, all the way down the basement is refreshment center. Okay, pop and stuff like that.
The quizzes we just take on our own time?
Yeah, on your own time. Yep. Yep. Anytime. If you can work ahead if you want to. Yeah, definitely. Yep.